Welcome to the first sprint demo in 2019 for Evernym's Indy team. We're the team that contribute to Indy and Sovereign. And in this demo, we're going to talk about some recent work on the SDK to improve error handling. And we're also going to talk about improvements we've made to Indy Node for how catch-up works, and also some work we've done that impacted the way the ledgers talk to each other. And so we did design for making sure that we can keep those ledgers consistent and auditable. So it's a fairly productive session, fairly productive sprint. This was an extra long sprint. We went 4 weeks, double length, because we had the holiday, the US holiday and the Russian holiday for the New Year, and they're a little bit offset. So we didn't get together as a team for a chunk of time. But most of our focus was on completing the work identified during the outage of the Sovereign network in early December. So we identified some changes that need to happen, and we got a lot of those bugs fixed. Hard to demo some of those. But we also have been working on permission schemes, improvements to the permission scheme, so a single trustee or steward can't take over the network. And as part of that, we've moved permission schemes to be tracked on the config ledger. But then came the question of, well, how do I know when I'm auditing the network that the permissions were in place on the config ledger at the time that things were done on the domain ledger? And so that's what caused us to look at the auditability requirement. So we'll talk about that more in a minute. On the SDK side, we have been very focused on, we've moved our focus away from the initial implementation of libvcx and been more focused on making sure that we're ready to, we can implement all the hypes, all the community standards for interoperability, so that agents can talk to each other. And we did a lot of prep on that this time, and we're gonna start working on that in the future, in the next sprint. And the error handling we're gonna talk about in more detail as well. We're gonna do a demo on that in a minute. One of the needs that was recognized is that we need a network monitoring role so that stewards can pay attention to what's going on the network without using their steward keys all the time. So we're almost done implementing that. I'm not quite ready for a demo today, but expect that in the next release. And we're trying to get a release done in January that contains these fixes that were identified last December. So that was the current sprint. So very good. With that, Artem, I'll stop sharing my screen. Hopefully that process goes well. Zoom's been a little iffy for me lately, and we'll let Artem share his screen. So, hey, it worked. Excellent. So Artem, you can share your screen. Looks good.
Okay, I'm ready to start. So my demo is about libindy error handling improvements. As you know, libindy is a C library which returns for every function error code. There are a lot of error codes in libindy. Some part of them were added for one particular case, like this one or this one, and it's easy to understand what actually went wrong. But some of them, like common invalid structure, invalid state, pretty wide. And it's not always unclear what actually happened, and only one way to get the actual reason of failed function was enabling libindy logging and looking into this log file to find the actual cause of problem. It was pretty inconvenient, and we often get a response from community members and developers to provide error description or some way to get it. And now I'd like to announce that we finally did it. So we added Indy get current error API function. This function returns additional message and optionally can return back trace for last error occurred in libindy. For directly libindy users, there are some restriction of how to properly use this function, because libindy is a synchronous library, and there are two types of error can appear in libindy: synchronous and asynchronous, and you should be careful to handle both of them. What about wrappers? This function is hid from users. All required changes already done inside of wrapper implementation, and returning error extended to contain additional fields like message and Indy backtrace. Now I'd like to little demonstrate how it works from a Python wrapper. I run this test which have to fail, and I set breakpoint on error test started. So we start here. Let's look into error and see here we see message description actually happened and also backtrace. We can easily view this and find what actually went wrong with Ubuntu. This line here we see function and exactly right where error was thrown. I'd like to notice that backtrace is optional, and to enable collecting of backtrace, you should either specify Rust backtrace environment variable, or you should call indyset runtime config function with collect backtrace param. But also you should be aware that this function should be called before any other libindy function. So as the next, I'd like to also show a little demo regarding libindy CLI, how what we get here. I have two CLI started, one from current code base with URL handling, and the second one from last stable version. I'd like to run two same comments and compare error messages we get. So let's type didn't use seed, and here I pass wrong seed, and we get following error, which is not really informative, and the user should go to open help for this command probably, or enable log and see format of parameter acceptable. And now I would like to run same command from new CLI. Here I pass wrong CLI, and here we get more clear error, invalid structure, and caused by invalid seed length. It's significantly simplify user experience, and actually it solves a lot of problems regarding creating new bugs in libindy. Now bug reporter can attach log, backtrace, and a message, and it's much easier to fix recurrent error in libindy. That's it.
Very good. I see Corin clapping, so thanks for that, Corin. This has been a frequently requested improvement to the SDK, so thank you, Artem and team, for getting it done. One question that I got as I was discussing this with Kyle, he wanted to know if this would help enable partial proof requests, if it's added to the proving areas of the product, such that a verifier can say, oh, this is why the proof failed, and decide if they want it accepted anyway.
Unfortunately, proof verification based on mathematics, and this mostly return only true or false value, and we can get any context what exactly went wrong, which attribute verification failed. But verifier can get a message if proof doesn't correspond to proof request he sent to prover or something in these cases.
Excellent. Thanks for explaining that. So partial proof acceptance or incomplete proof acceptance is something we would like to do at some point in time, but we're not going to get to in the next 6 weeks probably. So anybody who wants to build that, pull requests are always appreciated, and let us know and we can discuss with you how you do that. Excellent. So any other questions on error handling? Corin and James is our guest today. Any questions?
Not for me.
Excellent. Well, thank you. Feel free to ask any questions you have as we go through. So Renata, feel free to share your screen.
Hello. Hope you see my screen.
Looks good.
Today I will tell you about a new stashing mechanism. Why is there a need for a new stashing? Replicas discarded pairs receiving during catch-up. So if catch-up is long enough, it may lead to infinite catch-ups and a lot of requests for missing replica pairs. Since during a high load, the pool may order a lot. But other messages processing in catch-up, and in case with processing 3-phase messages, we can order some transactions during catch-up. It leads to other nodes blacklisting and catch-up can't be finished. In case with checkpoint messages processing, we will start catch-up one by one and never finished. In we change, we lost a lot of messages from previous view. In some cases, it leads to different states or nodes after view change. And in addition, stashing mechanism, last stashing mechanism, didn't have a clear architecture that leads to new bugs which are difficult to find. In a new mechanism, we have only one way to all kinds of stashing 3-phase messages and new classes for validation and stashing. Let's look at them. So it's a replica validator. We have validation methods for dividing all incoming messages to 3 types: messages for discards, for processing, and for stashing in some queues. And we have no replica stasher. That's received a message and a type with types from station from validator and stash it in an internal queues. Back to presentation. And for checkpoint messages, we add the same mechanism, but with other validation method, of course. We unstash checkpoint and 3-phase messages in following cases. In the end of view change for messages with a new view, when new primary are selected, already selected. In the end of one catch-up round, we update watermarks, unstash messages, which were out of watermarks early. After that, we unstash messages receiving in catch-up. The order is important because if we will process checkpoint firstly, we not needed catch-up and new catch-up will not be started. And we unstash our out of watermarks messages when watermarks are changed. The tests for a new logic, they'll pass correctly and task was finished. That's all. Thank you. Any questions?
Can you remind me, Renata, where did we find this problem? Was it in our testing, or is it one of the symptoms? Was it one of the causes of the problems that we found on the sovereign network?
I think it's not same problem as release network, but we found a new problem. Maybe it's not a problem with new stashing, but we open a new interesting bug.
Yeah, excellent. Well, thanks for taking us through that logic. If anybody is watching this video finds that catch-up process interesting, I highly recommend you go through the playlist. We have all our sprint demos up here, and Renata's done about 5 of these catch-up issues where she's taken us through what happened. And if you watch them all, you'll have a much better understanding of how Indy does catch up and really how RBF teams maintaining consensus. She's done, you've got about 5 of these slide decks now that taken together, I think, gives a good overview of the entire process. So recommend people do that. Any questions from Coroner James or other people who are watching live?
Nope.
James is new on the Evernym team, so don't feel bad if it's your first time through it's a fairly complicated algorithm. So
Yeah, I don't know what's going on, so I'm just watching, just observing.
yeah, fantastic, and we appreciate you joining. So, but definitely, if you want to understand the consensus better in the history on the Evernym YouTube channel, you'll find a few more of these. Anytime that Renata's name's in the demo, you'll see.
Okay.
She goes through this kind of thing. Okay, Sergey K is going to take us through the auto ledger design. As I mentioned, we recognized when we moved the permissions to the config ledger that it became harder to prove that people had the right permissions at the time they did stuff on the domain ledger. And we also found problems with catch-up, that sometimes the order of the ledgers wouldn't be exactly predictable. And so we talked about a few different ways to resolve that, and Sergey is going to take you through the approach that we've selected, working with the architects of the Indy community. So go ahead and share your screen, Sergey.
Okay. So can you see my screen now?
Yep, it looks good.
Okay, I'm going to start with describing why we need yet another ledger. Well, first reason is that since Indy Node can have many different ledgers, I'll call them here just ledger A and ledger B. Transactions in each ledger are ordered, but there is no order between ledgers currently. And if transactions from one of ledgers are dependent on others, then this can be a problem. First of all, of course, it's a problem for audit. And another problem which we already stumbled upon is catch-up problem. So suppose that we have 2 ledgers, A and B, and suppose that validation of transactions in A is dependent on contents of B. And for example, on the left, we have some lagging node, which started a catch-up, and on the right, we have a pool. Well, so a state of some normal node. So suppose that we have some lagging node which started a catch-up, and it caught up ledger A and is going to catch up ledger B. And at the same time, pool ordered transactions A1 and B1, but they obviously didn't get to our lagging node because it's in the process of the catch-up. Now, our lagging node catches up ledger B, and so it gets transaction B1, but it doesn't get transaction A1 because when it started catch-up, it wasn't in ledgers of other nodes. And now lagging node thinks that it's done with catch-up, it continues normal ordering and tries to order A1. And however, B1 prevents validation of A1 from succeeding, so we have inconsistent ledger on one of nodes and it falls out of consensus. At the same time, on the other nodes, A1 was successfully ordered before B1, so there is no problem for other nodes. And we considered many options and found that audit ledger probably is the most appropriate one. What we propose is to add a new ledger called an audit ledger, which has transactions which are added when new batches are ordered, and each transaction contains its global audit sequence number and links to other ledgers. For example, in this case, we can see that in the beginning we had ledger A containing 3 transactions and ledger B containing two transactions. And next batch didn't add anything to A, but it added 3 transactions to ledger B. So it grows from 2 to 5. And then there was a batch which added 1 more transaction to A, and then there was a batch which added some transactions to B again. So now we have a total order. We don't have to change current ledgers. We don't have to migrate data. And actually this audit ledger can also play a role of some index which helps making catch-up not only consistent but also very fast. Let's see how this goes. For example, no, let's suppose we have the same situation as described before without audit ledger. When doing catch-up, Legend Node catches up audit ledger first, so it knows which transactions it should catch up. Then it starts catching up other ledgers, knowing an amount of transactions to expect. And then it catches up ledger A, and after that pull orders A1 and B1. So in the end, we have this situation where on the Legend Node we don't have A1 and B1, and we don't have a new audit ledger transaction, and on the other pool, in the other pool, we have all of them. Now, Legend Node starts catching up ledger B. However, it knows that it doesn't contain B1, so it doesn't catch up this transaction. So situation stays the same, and after ending catch-up, it continues ordering normally and successfully orders A1, then B1, so everything is good. That's all from me. Oh, sorry. We also have a design document in Indy Plenum repo. It's called Catch-up and Audit Proposal, and it provides much more details on this. So my demo was well, I tried in the demo to be to focus on the not to focus on the details, but to give a understandable picture. So that's all from me.
Yeah, it's really useful. I think this is going to be a good long-term improvement to the system. Very good. So the moving forward, the Indy Node team is going to focus on getting this audit ledger done. We want to get that done in the month of February. We'd really like to see it released at the end of February. We won't have a definite timeline until we've started implementation, but that's the goal. We have as we finish that, we'll also be able to finish the permissioning improvements to move those to config ledger and require multi-signature for certain actions. So that'll be really useful. And then there's some additional work we need to do to improve the plugin handler for ledger plugins. So that's Indy Node over the next couple of sprints. Indy SDK, we're very much focused at the moment on improving, adding agent-to-agent compatibility by implementing the hypes that have been accepted. And we're going to produce some additional hypes around credential exchange so people understand how libvcx is doing that, and we can give feedback on improving that system. That's all preparation for the Sovereign Foundation's Connect All the Agents-a-thon. That's the second week of February. We want to get as much work as we can, so that's a productive session. So that's our plan over the next couple of sprints. We do expect to have the work we've completed now released by the end of January. So that's also going to happen in the next sprint. And then we want to have a release near the end of February that contains these additional improvements that are required for people to move forward in March with this system. Any last questions or comments from anybody? We're actually going to end on time. That's unusual for us. So thank you everybody for your participation. We appreciate the questions and comments from people who are attending live. We'll have another one of these sessions in 2 weeks. And if you're watching this on YouTube, you can always find us at the chat.hyperledger.org. We hang out in the Indy Node and Indy SDK channels. So thank you very much and have a good day.
Thank you. Bye.